And the next presenter is Anna from Polytechnic University of Tirana. And the title is Comparative Study of Phosphorite Deposits in Tethyan Phosphogenic Province, Active Exploitation in Turkey and Abandonment in Albania.
Thank you. Following up the discussions made by Catherine before, my presentation today will be focused on the famous Tethyan Phosphogenic Province, where Morocco make part as well. The today presentation will be focused on the results achieved until now of a project, of a bilateral project between Istanbul University and the Faculty of Geology and Mining in Tirana. You have seen this figure today several times, and why we have choose phosphite rocks for this project. Until 90s in Albania, phosphorites were actively exploited, but after 90s, everything stopped. And no one cares about phosphite rocks anymore. Based on the critical raw material list, together with our colleagues, we thought, why not to re-put attention to these famous deposits that were actively exploited before 90s in Albania. And for this, we thought that creating a collaboration with Turkey that is part of the same phosphogenic province, Tethyan Phosphogenic Province, could highlight several questions regarding this type of formation. Why, what kind of similarities have they between each other, and which are the differences between these two horizons. Okay. These two horizons, Cretaceous horizon, are part of these phosphorite deposits that their age date of Upper Cretaceous. They continue up to Eocene, but in Albania and in Turkey, they are localized only in Upper Cretaceous, in Conasian. And main deposits in the Mediterranean area are dated as Upper Cretaceous. You see this small laser, okay, this small dot, small, but before 90s it was very important in European continent. And you see here Albania, Mardin, these here in the Ionian zone and in Mardin are located the two study areas that are part of this project. To better understand the situation of phosphorites in Albania and in Turkey, we have to travel back in time and to see how the paleogeographic conditions were during Upper Cretaceous. And based on this, we can see the paleogeographic map during the Upper Cretaceous, and with this place mark shows Albania position, and more to the southern part is located Turkey. And we can see that actually during Upper Cretaceous, Albania was located in higher latitudes, and these can be a key fact or a very important let's say fact to further interpretation why the grade of Albanian phosphorite is not as high as those of Mardin of Turkey. So we should keep it in mind, this paleogeographic map during our interpretations. So what is the current situation in exploration and exploitation in Albania and in Turkey, respectively? As I said before, in Albania, everything stopped at the end of the 90s. The end of 90s corresponds with the end of communism regime, and the main industries collapsed. Some of them were just left behind. Some of them were officially stopped. While in Turkey, the exploration and exploitation is currently very intensive, let's say. As you see, in Albania were used 60,000 tons of reserves, with the content of P2O5 was the average was 20% of P2O5. In Gusmari deposit, the P2O5 went up to 30%, so it was very rich, but it was all of these high grade ore were exploited and were used. No traces of such type of ore are found anymore. And based on the old studies, previous studies, there are estimated that 57 million tons of geological reserves are calculated to be present in such type of anticline structures that are present in Ionian zone. While in Turkey, there is I don't know if someone of you knows Eti Gübre, which is part of a famous group, Cengiz Holding in Turkey. They have invested almost 2 billion euros in this company, in this industry, and they are currently producing phosphoric acid plant and fertilizers. Very huge, big, a very serious company. A few words regarding geological map on the geological setting of Albania and the location of these anticline belt. Albania is a small country, but its geology is fascinating because in a very narrow area, a very small area, we have sedimentary rocks, we have the entire column of ophiolites. So our Albanian ophiolites are famous all over the world. So let's turn back to sedimentary phosphorites. They are located in the Kurveleshi anticline belt, that is a part of the geological tectonic zone, Ionian tectonic zone. You can see here the geological map of the richest deposit in Albania, in P2O5, which was Gusmari deposit, and these are the this is the location of the exploited level of phosphorite rocks, and the second one is here. Is Fushbarda deposit, where the grade wasn't so the P2O5 content wasn't so high in comparison with those of Gusmari. The P2O5 content went up to 20%. As I said before, everything stopped, was abandoned. That's why I say in the title, abandoned mines of phosphorites in Albania, because it looked like it was a cutting process after the end of the 90s. This is the generalized stratigraphic column of the Ionian zones, where we can see here in the upper Cretaceous is the phosphatic horizon of Connassian age, but even that we are in this study, we are focused only in the Upper Cretaceous. I would like to mention also another one, very important horizon, which is Lower Jurassic phosphatic horizon. It is very important because this horizon, based on the data that we have until now, is very high. The uranium content is very high in comparison with those of Upper Cretaceous. The uranium content is up to 1,700 ppm here, and based on the historical data that we have until now, the locals that have lived in the surrounding of this open pit mine quarry have faced several problem issues during the exploitation of the open pit quarry. The second study area is located in Turkey, in the famous Arabian Plate or Arabian Platform, which is an important tectonic unit of Turkey, and the main zone or the main area of this Arabian platform that serves as the main contributor to phosphatic exploration and exploitation is Mazidai. It's a region, and here are located this. In Mardin is located even the EGT-TWINN company. Here, the Shemikan phosphorite deposit. Mardin is the area. Shemikan is the exact place where the company, the EGT-TWINN company, has constructed their facilities to explore and to exploit the phosphorite deposits. You can see to the right part of the slide, there is the stratigraphic column of the Derik Mazidai region. It was compiled by our colleagues that are part of the project, and you can see that the most important part of this section regarding phosphorite is the Karababa formation. That consists of 3 units of Tashit, Kashrik, and Shemikan. And I said before, Shemikan is the main unit with this entire formation because it's the richest in P2O5. The average P2O5 content is around 18 up to 20% P2O5. Let's have a look to the abandoned Gusmari deposits. This is a collapsed open quarry of abandoned Gusmari deposit, and you can see they show the Upper Cretaceous phosphorites show a typical texture, laminated texture, where this lamination is due to the intercalation between pure carbonates and phosphorites. So this is a typical texture that is this type of texture is present even in Gusmari and in Fujbarda, in both deposits. We have made also some Geiger-Müller tests here in Upper Cretaceous. Both of deposits shows normal data regarding the radiation. So we suppose that, and in fact, based on the geochemical data that we have, that we achieved until now, the uranium content is within the normal range. These are some micro photographs taken from thin section prepared from Gusmari, where you can see the intercalation of phosphatic lamina that are the with dark color, brownish dark color, intercalated with micritic small lamina. And this is in these formations, there are also global trocanic tectonic foraminifera that confirms the upper Cretaceous age in both deposits, in Fushbarda and in Gusmari. Also, there are some pelloidic phosphorites and coprolite phosphorites, and also based on the same EDS data that we performed in University of Milan, Department of Earth Sciences, there are some very nice pictures of apatite crystals that form kind of spherolytic around the calcite crystals. These are the data achieved from the same EDS, where we found within cavities small phosphatic pelloids, and these are made of pure they consist of pure apatites. The main one of the goals that we have achieved until now is the discovery of uraninite within this formation. I emphasize this because it wasn't found before. It's the first time that we have detected this type of mineral in such type of formation in Albania. They are tiny, but they highlight also the formation conditions of this type of deposits in Albania, because uraninite, hexavalent uranium, usually in reductive environments precipitates like tetravalent uranium, forming what we call uraninite. So it's the first time that we have found in this type of formations. These are some clusters of uraninites within ghost structures of probably fauna, microfauna. The same situation also in Fushbarda deposit, where you can see the texture is identical to the Gusmari deposit. These are some field photos from the field work carried out in Mardin, in Shemikan, where you can see the active exploitation of this company in this area, and the fertilizer that they produce from these formations. Two are the typical formations within this huge Karababa formation, reddish one and the cream phosphorite. They are very, the strange thing is that we are in the same phosphogenic province, but macroscopically and even microscopically, they are totally different from ours, because they are almost, they look macroscopically, they look like sand, beach sand. They aren't well cemented, while in Albania they are well cemented, very hard to to hammer it. So very different from macroscopically and even microscopically. These also some other pictures during the field work, and these are microphotographs of the thin sections prepared from the amylase. So just a couple of words regarding the geochemical differences in these reddish and creme phosphorites in Turkey. Creme colored phosphorites are enriched in uranium, and in comparison with red phosphorite, they are enriched in aluminum, magnesium, and other elements that, and it also in rare earth elements. While in Albania, rare earth elements are in very low quantity. So they, until now, we don't have data that can suggest to us that we are we can find it. We found a new deposit of rare earth elements. In Albania, these level of phosphorites is related with ocean anoxic events that you mentioned before as well, and it's both of horizons in Albania corresponds to two very important ocean anoxic events. The first one with Konyassian-Santonian ocean anoxic events, and the lower Jurassic with early Toarcian and ocean anoxic events. Which was the mechanism of formation of these phosphorite deposits in Turkey. It involves the pumping of nutrient-rich I forgot the term, where oxic deep ocean waters are coming into shallow waters, where they bring nutrients and coming by bringing nutrients, the microorganism evolve, blooms, and form the major source for phosphorite deposits. I want to thank you all for the attention, and I would like also to remind that project for funding our participation in this conference, and also Nasri and Tubitak for funding the bilateral project. Thank you. So you should put an eye on Western Balkans for phosphorites, not only on Northern Europe. Thank you.
And maybe very quick one question, if there is anything really burning. If not, you can ask during the dinner. Thank you, Anna.